Hey everyone, welcome back to the channel. So today we're going to turn Wikipedia into your personal stock market data source. That's right, in just a few lines of Python code, we'll scrape the entire S&P 500 companies list, we'll add clickable links for each ticker, and we'll export it straight into a CSV file that you can use for analysis. So if you've ever wondered how to automate your stock research or build your own data set without paying for expensive APIs, this tutorial is for you. And don't worry, I'll explain every line of code so even beginners can follow along. And by the end, you'll have a working script that prints the table of stocks in the S&P 500 to your screen and saves it to a CSV file called S&P 500 stocks. So let's dive in. Right now, I'm currently on Google's website. It's called colab.research.google.com because it makes it easy to get started programming in Python. So if you're going to program along with me, you can go to this website or use your own IDE to get started writing your Python code. All right, so let's go ahead and get started. I'm going to go ahead and click on File, and then I'm going to click on New Notebook in Drive, which will open up a new tab for me, and it will eventually open up a new cell for me. All right, so here we have our cell. We have some message here. So we're just going to click that. That's Gemini, Google's Gemini, that can help us write some of this code. All right. So the first thing that I'm going to do is I'm going to import the libraries that I need for this program. So I'm going to import request, and this library will fetch web pages. So I'll put that here, and maybe I'll just put used to fetch web pages. All right. Okay. Next, I'm going to import pandas as PD, and this will be used for handling and analyzing tabular data. All right. And you know what? Also from IO, I'm going to import string IO, which is used to simulate file objects just like Google suggested here. And I'm going to just tab over to put those comments. All right, so let's go ahead and run this cell by clicking this button here to the left, and this will let me know if I made any mistakes. In the meantime, I'm going to go ahead and click on this tab up here, and this takes me to Wikipedia. So hopefully y'all can see this very well. I'm going to zoom in a little bit here for you all. All right, so here is the Wikipedia link that we're going to be using, that we're going to be scraping. So on this link or on this web page, we have this nice table that has the list of S&P 500 stocks. And you can see over here to the right, I'm looking at the HTML code for this web page, and we can see the table here, right? So it might be hard for you to see. I'm not sure if I can make this bigger. Let's see. There we go. Perfect. So here we can see the table, and inside of the table, we have some columns, right? So here is our columns. So here's one of the columns, and this column's name is symbol. So we can see symbol right here. All right, and it contains all of the symbols, all the stock symbols in the S&P 500. So we're basically going to go through here. We're going to grab all of these columns. We're going to scrape them, and we're going to print it to the screen and then add it to a CSV file so we know all of the companies in the S&P 500, at least according to Wikipedia. All right. And then after that, we're going to create a link. So I'm going to go to this second link that I have here, and the link will look something like this. I actually put in, instead of alphabet underscore inc here, I actually put in GOOG, and it redirected me to Alphabet Inc. And so this right here will allow us to basically create our link by appending the stock symbol at the end of the link here, and it can take us to the web page about the company that the stock symbol belongs to. Okay. All right, so let's get back to the code. Looks like there was an error. So here it says import request, no module name request, and that's because it's called request with an S. So let's go ahead and put that S there. Let's go ahead and run this cell again, and there we go. All right, so right now it's looking really good. We're going to go ahead and create a new cell by clicking that code button in the top left. And now here, what we're going to do is we're going to define the URL of the Wikipedia page, which I talked about. And I'm going to put specifically the Wikipedia page containing the S&P 500 companies. All right. So I'm going to create a variable called URL. Oh, looks like Google might have already had it for us. I'm going to set it equal to, let's see if it pops up again. It didn't. So I'm going to put in a string here, and it's going to be https://en.wikipedia.org, which is what we see here, /wiki/list underscore of underscore s, and then %26p underscore 500 underscore company. So this is perfect. Google knew exactly what I wanted to do. So I'm just going to tab over. And I'm going to go ahead and run this cell. All right, so now that's our URL. Let's create a new cell here. Okay, and here we're going to create a, and I'll put in comments here, create a headers dictionary. And we're going to do this to mimic a browser request. Okay, and this right here helps us to prevent 403 forbidden errors. And I'll put that here. Help to prevent 403 forbidden errors. Okay. All right. So I'm going to create a variable called headers, and I'm going to set it equal to a dictionary. And that's just a key value pair. So it will be user agent will be the key, and the value will be Mozilla /5.0. All right, and some historical facts about this. So back in the, I don't know, 1990s, approximately 1990s, Netscape had a browser, and it was like the dominant browser. So Netscape's dominant browser. Now Netscape's browser, I believe, is Firefox. But back then it was called, I don't know, Netscape Navigator, something like that. Don't quote me. Anyways, back in the 90s, they had this browser, and its code name was Mozilla. And many websites optimized for it to ensure compatibility. Other browsers like Internet Explorer started calling themselves Mozilla too. And this 5.0 is actually a version marker. The 5.0 indicates the version of the rendering engine, and it doesn't mean that this is the version of Firefox now, or the version of, yeah, Firefox now. It's not a version of the current Mozilla browser. It's just a legacy convention. And so today, almost all browsers start their user agent string with Mozilla 5.0, even if they're using Chrome or Edge or Safari or Firefox. It's basically like a universal handshake that says, hey, I'm a modern browser. Please don't block me. All right. So that's kind of the history here. That's why we're using this. That's why we're using this Mozilla 5.0 header. So it's just to tell the, it's just to say that we are a modern browser and we don't want it to block us. So it's going to help us prevent that 403 forbidden error. So I hope that made sense. I might have stumbled over my words a little bit, but that's the basic premise of this. Let's go ahead and run this cell. Let's create a new cell. All right. And now what we're going to do is we're going to send a GET request to Wikipedia. So let's do that. Let's send a GET request to the Wikipedia page. So I'm going to create a variable called response. I like what Google put here. I'm just going to tab over. All right, so it's response. It's setting response equal to request.get URL, and then to the headers. or setting headers equal to headers, right? So basically what we're getting here is we're getting the raw HTML from that web page. So we're getting all of the HTML. All right, so I like that. I probably should have put all this in one cell, but this is good. I'm just gonna go ahead and run this cell. Let's create a new one. We'll just keep doing it like this for now. Okay, so next I want to parse all of the HTML tables, and Python gives us a method to do this, and it makes it really easy for us. So we're going to do this using a method called read_HTML, which will convert every table it finds into a data frame. All right. So I'm going to create a variable called tables, and I'm going to set it equal to pd.read_HTML. And I like what Google put here, response.text. So I'm just going to tab over, and I actually want to use string IO. So I'm going to put that right here. String IO, left parentheses, right parentheses. So string IO wraps the response, and actually I'm going to put some comments here. String IO wraps the response text so pandas can read it like a file. Okay, and that's all it's doing. So let's go ahead and run this, and now we got our tables. Let's create a new cell. Okay, and let's see, what do we want to do? Let's go ahead and initialize a variable to hold the correct SMP 500 table, which I believe there's only one on that web page, but the one that we definitely want will have that column called symbol. So let me first create a variable called SMP 500 underscore table. I'm going to set it equal to none for now. And then I'm going to loop through all of the tables found on the page. So for table in tables, right? Because tables will have all of our tables, thanks to that read_HTML method. Okay, so for table in tables, we're going to check if the table contains the correct information. I like that. I'm just going to tab over. So we're going to check to see if it contains the correct information, which is the column named symbol. And I put which is the column named symbol. Okay, so if symbol is in table.columns, just like Google put here, then the SMP 500 table we found. So we're going to set SMP 500 table equal to table. All right, we found the table and we're done. We'll need to do anything with any other table on that website. So I'm just going to break. Okay. All right. Now let's see the if there is no table. So we'll put here if no table with symbol column was found, then raise an error. So we should find a table called or a table with the column symbol. But if we don't, then I know something's wrong here. So I'm just gonna tab over here and create this check. So if SP 500 table is none, so if it's still nothing, right? So it never went to this, to this statement here, it's still none. Then okay, we can raise an exception. or actually we're going to raise a value error, or we could just do a print statement. All right, so that looks good. Okay, so next let's go ahead and let's get ready to create a link to each of the stock symbols. So here we're going to define the base Wikipedia URL for linking each of the stock ticker symbols. All right. So now how do we do that? Well, oh, Google already helped us out here. So this will be the base link. So we're going to create a variable called base URL is good. I'm just going to tab over. And so what we're going to do is we're going to append at the end of this URL, we're going to append something like AAPL, like Apple, right? So now the link will look like this once we append that base link to each of the symbols. All right, and this will allow us to see more information about that stock symbols company. Okay, so this will be our base URL for now. Let's see what Google put here. Loop through each of the stock ticker symbols. Absolutely, that's exactly what we want to do. And there's an easier way to do that though. We can actually, I like that. We could loop through each of them and then append this, but instead, what we're going to do is we're going to create a new column called symbol link, because we already have our data frame, S&P 500 table. So I like what Google put here. I think that'll work. So I'm going to tab over S&P 500 table. Symbol link is going to equal, yeah, uh, base URL plus symbol. That should do it. Another way we could do it is we can create a function where we apply the function, or we can create like a lambda function and apply that as well. And just to show you what I mean, let's go ahead and do that actually. So we'll keep the symbol link column, okay? And we're going to set this equal to S&P 500 table. Oh, Google's doing exactly what I said. So I'm just going to tab over here. And what it's doing is it's applying a lambda function, which is a small anonymous function defined with the keyword lambda. And it's going to take in some value x, and then it's going to return that base URL plus x. All right. So we can do it that way, or we can actually create a function like a function called make link, takes in symbol, and then we could return the base link plus the symbol, and we can just apply that function instead. And I can show you what I mean by that. Let's go ahead and do that. Let's do that also. Okay, so I will from here. I'm just going to do def make underscore link symbol just to show you what I'm talking about. And it's going to return. It's going to return this here plus the symbol. Okay, and just to make sure that we're doing a string, we can make it a string. Make sure that symbol's a string here. Okay. Oh, and then we would apply. I like the lambda function. I'm just going to copy this. Okay, so then we would just apply. We would apply make underscore link. And then that should do it. So let me comment this out for now. And just so I don't have to rewrite, just so I don't have to rewrite that lambda function, I'm just going to put it here for now, and we're commenting it out. All right, so let's see if this actually does it. Okay, I like that. Now I think we're really done, right? I spent enough time on that. So here we're going to print the, make that a capital P, print the first 10 rows of the table. So we're going to print S&P 500 underscore table dot head, and then we're putting in the value 10 to print the first 10. And we're using head to print the first, right? So dot head prints the first 10. If we did dot tail, it would print the last 10. If we did dot tail 10. So we're doing dot head 10 here. And let's go ahead and save this to a file. All right, so that's easy enough. SP 500 underscore table dot to underscore CSV. And we're going to call this S&P or SP 500 stocks dot CSV. And let's set the index equal to false. So this ensures row numbers are not included in this CSV file. And I think we got it. Let's go ahead and run this cell. That's a lot. All right, there it is. Okay. And here are our links. So I can click on these links here and get some information about the company that the symbol belongs to. And if I come over here to the files folder, I can see my CSV file. Let's go ahead and double click that and exit this pane. And now we can see the CSV file here. All right, pretty cool. We have 503 entries. I'm just gonna go to the second one here. We can see we have Google in the S&P 500, and it's headquartered in Mountain View, California. And we have a nice link that will send us directly to the link that you saw above there. All right, so pretty cool. And that is basically it. So there you have it, your very own Python web scraper for the S&P 500. We pulled the data straight from Wikipedia, added a column of clickable links, printed the table, and saved it to a CSV file. It's simple, it's powerful, and ready to plug into your financial analysis projects. So if you found this helpful, then please smash that like button. Don't forget to subscribe for more Python and finance tutorials, more more programs on machine learning as well. You can be found on this channel. And drop a comment below with what you'd like me to scrape next or what you'd like me to program. And you can get this code from this video on Patreon at patreon.com/computerscience. Thanks for watching. Keep coding, keep investing smart, and I'll see you in the next one. And don't forget, this is not financial advice. All right. Thanks for watching. Hope you guys have a great day. Bye bye.